remember her name yesterday, but I joined her channel when it was brand new. Well, it was available for so many individuals before things changed. So I happened to find out her name and things like that there. So she spoke about the three-digit computer that the Soviets had, which was beaten out by the binary computers. Now, the three-digit computers from her presentation were faster and better. So a 10-digit computer using decimal should be as well, right? Now, let's talk about what binary numbers are and what decimal numbers are. Now, the binary numbers are denoted by a 0 and a 1, and they are also called 0 and 1. The decimal numbers are denoted by 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In decimal, you can take those 10 digits, that's why it's called decimal. You can take those 10 digits and make any number. In binary, you can take those 2 digits and make any number, right? So why is binary numbers the digits called 0 and 1, and why are they also called 0 and 1 in decimal? They are not always equal. In certain special cases, they're equal. But they look the same, and we're familiar. We call them 0 and 1, and it continues, I guess. I don't know the real reason. You could call it true or false. So that helps, I guess. Again, binary numbers are denoted by the digits 0 and 1, and any number can be represented by a string of 0 and 1. All the information on our computers today, to my wit, are somehow mapped onto a string of 0 and 1. The decimal numerals are, the highest one is 9, the lowest one is 0. Between 9 and 0, you have 8, 7, 6, 5, 4, 3, 2, 1. Right? We all are familiar with decimal numbers, and the decimal numbers make any numbers we use that we're familiar with, that we're able to manipulate more or less manually. So computer engineer Anastasia in one of her presentations said the Soviet 3-bit machines were better and faster, but the 2-bit machines beat it out. If the 3-bit machines were better and faster, the 10-digit machines should be better and faster too, by orders of magnitude. But not necessarily.